Okay, guys, so in this example, we have our same sequence, and we want to evaluate terms using sequence notation, but we're going to look at what's known as the recursive process, okay? So before we just looked at the term number and found it, the recursive process works a little differently. It's like a two-step problem. So if it says, this first problem says, if n is equal to 3, find a to the n minus 1. So what we're really looking for, we're saying, okay, so n is 3, so we're trying to find the third term, but a to the n minus 1 says find the term before it, right? Because a to the 3 minus 1 is really equal to a to the 2, right? So we're really looking for the second term there. So a to the n minus 1 is the second term. So we just come here, the second term is 3. And so let's do another example. We have if n is 8, find a to the 8 minus 1. So again, so if we're looking at the 8th term here, a to the n minus 1, all this means is find the term before it, because 8 minus 1 is 7. So we're really looking for the 7th term. So 1, 2, 3, 4, 5, 6, 7, that's 13. Okay, so we could say a to the n minus 1 in this case is 13. So we'll go over one last example. Let's say we had the n is 5, so we're looking at the 5th term, and we want to find a to the n minus 1. So we're looking at the term before it. Remember, a to the n minus 1 just means find the term before it. So that makes sense, because if we actually plug that 5 in, right, a to the 5 minus 1 would be equal to a to the 4, which is the term right before the 5th one, right? But we can skip this step from now on and just look at a to the n minus 1 as it being the term before. So the 4th term is 1, 2, 3, 4, so that would be 7. So whenever we're looking at this recursive process, all we're looking at is the terms before whatever term is given to us.